Okay, so I'm just going to do a general question. Um, it covers quite a few things, and I might just add one or two questions as well from my if I see. So it looks like a full question, and it's actually from the 2019 trial exam that they wrote 2 years ago. 18 marks, as you can see, grade 12 paper, but 100% grade 11 work, right? This is all 100% grade 11 work. The same levels of testing, maybe if there's one or two, but this one there's not even one or two grade 12 content things tested. So 100% grade 11, and that's what they do, right? Grade 12 is about 60% grade 11 work. So whatever you're doing now, try to master it, try to master the concepts that even she says she might not put in the paper or whatever, because it's going to be there next year, and they don't reteach it. They just assume that, grade 11, you should know it. It's easy, but it's not actually easier. They just add it to the work. So it's like they're testing last year and this year together mixed, basically. So grade 11 work, you can call what you're doing now matric work, because this is a matric exam for 18 marks, which out of a paper of 150 is about, what, 9%? No, 10%? 10% of the paper, basically, around, no, more than 10%, yeah, around 12% of the paper, that is. So yeah, let's get into it. First thing you do is try to color coordinate. Try to always take a highlighter or a color pen and try to just go over certain things just so I know what's what, and I look at it in terms of colors and patterns. So negative x squared plus 5x, that's graph of f, right? And whatever they mention f, just so I can see it in terms of the color and don't think of it in terms of the parabola, right? So, but we know it's a parabola and we know the properties of a parabola, and yeah, so whatever they mention m as well, or a, because it lies on a, because it's part of that function, right? So a, b and c, yeah, also function f. Okay, let's take a different color. Let's go here. It's a bit thick, isn't it? Yeah. Okay, that's g. So g is the graph of x plus 1. That's a nice graph. G, where I see g. Okay, they didn't mention g too much. Yeah, alright, that's fine. Fine with us. Let's go. So I haven't seen this question before. Like, I haven't tried answering up. This is the first time I'm looking at it. I just pulled it out from the stack. So write down the coordinates of a. Where's a? Here. So a is the y-intercept of the parabola. That's easy enough to get. It'll just be our c value, which is 6. So we write this as 0, 6. Okay, that's all. They don't want any long stories. 1 mark given, right? If they make it 2 marks for you or 3 marks, then what you would do is let this equals let f of find f of 0, basically. So wherever there's an x plus 0, you'll end up with 6. Okay, nothing major there. So that's our answer here. Just 0.0 and 6. So we can add that in there since we know that a is 6. Next one, s is the reflection of a about the axis of symmetry of f. So what is the axis of symmetry of a parabola? It is the line that comes down here in between. It basically makes the parabola symmetrical on both sides. It's also the x value of the turning point, right? And it's the number that lies directly in between the intercepts, right, on the x-axis. So this distance is automatically equal to this distance because of the axis of symmetry and its definition, right? So let's look at what they asked us to find. So S, now what is S? We don't know. Is there an S? Oh, there is an S. Look there. Cool. Maybe they're talking about that one. Is the reflection of A, this point here, okay, about the axis of symmetry. Calculate the coordinates of S. That's not hard. What are they telling us? They're telling us, let's see this green line that I drew in there. Should have continued a little bit more. That green line, right? Tell my cat. This green line is dividing this parabola. So if you fold the page there, the parabola will be in exactly the same place, right? So we agree that the y value of A has to be the same as the y value of S, right? Because if you're folding up the page that way, on that, it's going to be at the same point. What's going to be different is the x value, right? Because here the x value is 0, here we don't know the x value. But how do you find the x value? Well, S is a set of points, right? So S is going to be, we don't know the x value, so we put x, right? And we know its y value is going to be 6, the same as A. Why do we know that? Because they told us it's reflected about the axis of symmetry, right? So it's in the same plane. So this is a 6. And we can substitute that into our equation that they have given us, in fact. So yeah, so if you're doing your formal working on your exam page, you look at this, you'll say f of x is equal to negative x squared. Where are we getting this? The equation that they gave us, plus 5x plus 6. And we're substituting this point here, right? The green. So when f of when x is x, we don't know what it is equal to 6, okay? So for some value of x in this function, we get 6. So we substitute, but there's nothing needed because x is there, minus x squared plus 5x plus 6. Remember, f of x is equal to this, so this whole thing is equal to that whole thing, alright? Is equal to 6, okay? Now the 6 cancels out. What do I mean by cancels out? Well, if we use an algebraic method and bring it over, we're going to get 6 minus 6 is equal to 0, so our equation is negative x squared plus 5x is equal to 0. Remove a common factor of x, and then we get negative x plus 5. Your teacher will tell you to change the signs and all that. You can do that. Same story, right? You get the same answer. Is equal to 0. Therefore, x must equal to 0. No, x is not equal to 0 because we already used that point over here, right, when x is 0. So 0 and 6 we used already. But we want to find the other one. And continue solving, or negative, the bracket, right? Negative x plus 5 is equal to 0. Therefore, negative x is equal to negative 5. Therefore, x is equal to 5, right? And that's our x coordinate. X is equal to 5. Put that there. And that's all they wanted, okay? Now, 2 marks. It's not a lot. It really isn't. Now, the coordinates of b and c are our roots of the equation. To find the roots of the equation, what do? You know this one, right? You say let f of x equal 0, okay? F of x is negative x squared plus 5x plus 6 is equal to 0. Now we change the signs. X squared minus 5x minus 6 is equal to 0 because we want to get a positive a value here, which is positive 1. So we can multiply every number here across by negative 1, changing all the signs, okay? And then now factorizing this, we get x plus x. No, what is this now? No, the equation's right there. X minus 1, x plus 1, yeah, okay, good. X minus 6, and then we get x plus 1 equals 0, and we've got x is equal to 6, or x is equal to minus 1, and that's that. That's our, now they want it in terms of coordinates, so be very, very careful. So you'll say A is obviously our negative 1, sorry, B and C, they wanted B and C. So B will be this one. B is negative 1 and 0, and then C is 6 and 0. Why? Because that's our roots. So now we know this here. The value of this here is going to be negative 1, and the value here is going to be a 6, okay? And there we go. Now, if PQ is equal to 5, calculate the length of QR. PQ equals 5, QR is where? PQ is 5. What's PQ? This is PQ. Let's get rid of everything else so we're not confused. Now we want that line. Just don't want that one, right? We know the coordinates of S and all of that, right? PQ, let's focus. Let's frame the question and see what's going on exactly, okay? PQ is this line here. So PQ is the distance between the the y value of our parabola and the y value of our straight line, isn't it? Q is on our straight line, and PQ is the distance between the y value on the parabola of P and the y value of the straight line at Q, right, for the same value of x. So how would we show that algebraically? Algebraically, this means how do we find any y value on our graph? That's what we have the equation for. This equation tells us all possible y values. So where f of x, with the y value of f at x, the y value of f at x, right, is, and we're minusing, because we're finding this length here, the y value of g at x, the y value of g at x, right? That's what PQ is. Isn't that so? And it's telling us that it's equal to 5. So this is equal to 5. What is QR? Well, that's nothing major. Why? Because we know these values, we can substitute it, right? So we negative x squared plus 5x plus 6 minus the whole of g, which is x plus 1, right, is equal to 5. Bring this out a little bit. X squared plus 5x plus 6 minus x minus 1 minus 5 equals 0. Negative x squared minus 4x equals 0, because 6 minus 1 is 5, minus 5 is 0, right? So change this, make that x squared plus 4x equals 0. Remove common factor, x plus 4 equals 0. Therefore x must equal 0, which is not true. X is not 0, yeah? Or x is equal to 4. Yes, can x equal 4 at point R? Yes, of course. So x is 4. And if x is 4, you can find, it's for 4 marks. Okay, cool. And if x is 4, right, we can find the y values, can't we? How do we find the y values? Put it back into the equations, right? So put it in here and put it in here, which means putting it in here, right? And, what? They just wanted the length of QR. Oh, QR, okay, so which means they just wanted the y value of Q. They only wanted the y value of Q, okay? So, what is the y value of Q when x is 4? How do we find that? Well, we know a magical method of finding any y value if we know its x value. That's called its equation. So g of 4 is going to equal 4 plus 1. You see, in place of the x, so g of 4, which is the y value, which is essentially from R to Q, right? Does that make sense? 0 to that, R to Q, same distance, is going to be 5, okay? Therefore, QR is equal to 5 as well. Now then they want us to calculate, yeah, then that makes sense. Calculate the coordinates of M. M is what? Let's get rid of all this extra nonsense that we don't need. So in the exam paper, you'll be using a pencil, right? Oops. So M is our turning point. How do we find the turning point of a parabola? Well, you know the axis of symmetry. We can substitute the x value here and get the y value. The x value here we know. How do we know? We can find a number of ways. But isn't I told you that the axis of symmetry's x value lies there perfectly in between -1 and 6? What number is between -1 and 6? For this length here to be the same as this length here, what must this be? What number is directly between -1 and 6? I think it's 3, 2, what? I'm not entirely sure. 7 over 2, which will be 3.5 actually. 3.5, which is 7 over 2, right? So the answer is 7 over 2. So put 7 over 2 into the equation of this parabola, and you'll find the answer, right? On the calculator, put it in there, and that's your coordinates for M, okay? Is it 7 over 2 though? Yeah, no, it is. Wait. No. It's not. What am I saying? No, it is. No, it'll be 5 over 2. I think it'll be 5 over 2. Anyway, just add this and put it over 2, basically. Nothing major. I'm just overcomplicating things. Never mind. Yeah, no, answer's 5 over 2. 5 over 2, sorry, yes. That's better. Now, the maximum length of P, this one that gets most people, this is a, I won't tell you anything now. Maximum length of PQ between B and S. What does that mean? What does it mean? What does people talk? What is rubbish people talking? Okay. Maximum length of PQ between B and S. Where is B? Find B is here. S is here. Between B and S. So the maximum length of PQ between B and S. So what is the greatest number that PQ can be between the points between here and here? How big can PQ get if we had to take it? We had to take PQ. Now let's use a nice different color. Okay, wait. Uh-oh. What I did? Okay. Draw, right. Okay. Let's take a different color. Take this ugly one. Okay, right. This here. Yeah, can you see that? So basically, we're taking that line and we are in fact moving it across here, but as we're moving it across, never mind. As moving it across, it's fitting. Basically, when you subtract the two graphs, what's the biggest number that you can get? right? At which point would you get the biggest number? So the maximum length of PQ and BS. So the method that Mrs. Smorgas taught me, which works wonderfully, is just find the difference between the graphs, so f of x minus g of x, and use turning point formula, right? So f of x minus g of x, and use the turning point of this. So we established that f of x minus g of x is going to be this here, didn't we? Negative x squared minus 4x. Negative x squared minus 4x, right? Which is equal to, you can use it from, you don't need to redo all of that, you can just say from that question, right? Turning point, let's see, remove negative as a common factor. I haven't done this in months, oh my god. Okay, that's x squared minus 4x. We just need to put a 2, yes, we just need to put a 2 plus 2, but then also a minus 2. Okay, wait, we see. No, we put a 4, yeah, right? And then we put a negative 4, because we have to take the 4 out again. No, not yet. And then we subtract 4, and then this becomes one thing, and that becomes another thing, and that's negative, and this becomes x minus 2 squared minus 4, and then this becomes, bring our negative inside, and that becomes, oh, did you want to know what I did here? Right, sorry, I wasn't explaining. What we did is basically the objective is to make it a perfect square and plus some. We just want a perfect square, right? Because we like when things look nice in a binomial bracket, okay? So firstly, we need to isolate it. We don't want negatives inside, because now you can have a square with a negative. So that leaves us with x squared minus 4x. So we need to make it a trinomial, right? So you take this number here, you divide it by 2, and then you square it. That just happens to be the same number but positive, because negative 4 divided by 2 is negative 2 squared is 4, and you add it. Then you put your trinomial in brackets, and you subtract this number. Because we did a sin here, right? We did a sin. Why we did a sin? Because we know it's equal to some. We don't know what it's equal to. But we know that it has a value. But we're adding to it and changing that value. Isn't that disgraceful? That is sinful, right? And man, you can't just add to an equation. You're changing its value. That's wrong. So we take the value out again, right? We take the value out again, and that makes it all okay. So like you're doing a sin, and now you're paying for it, okay? And then this becomes a perfect square. If you had to factorize, you'll find that. And that becomes x, and you put your sign from here, negative, and you just take the square root of that one, right? Which happens to be 2 minus 2. Okay? You put the square. Sorry, what happened here? That's supposed to be a 4, right? Negative is still there. Bring this down, and then now bring the negative inside, and we get is equal to negative into x minus 2 squared plus 4. Why? Because negative times negative is plus 4. And this is our maximum value. If you use it, just take that number, and our answer, we just put it over here, and we say 4. Right? That is all. Now what's freaking me out is a little bit is because we established that PQ was equal to 4, did we? No, they told us PQ was 5, but now we're saying the maximum value of PQ is 4. But anyway, algebraically it all looks good. I'll just double check this with the memo and let you know, but that's how I would go about it. I saw it for the first time, and yeah, just know certain things like that. I'll cover shifting with you. I'll look for a question with some nice shifting where it goes up and down and left and right with P's and Q's and all of that. It's actually quite nice because it's just moving the numbers a little bit, that's all. But they make it seem so hard with the way that they ask it. Let's do one actually. Let's make one up. Let's say that, take all this nonsense out. I'm asking you for what values... Okay, now find the new turning point of f if it is shifted 2 units to the left and 1 unit up. 2 units to the left and 1 unit up. So this increases a q value, and this decreases a what we said? This increases a p value, right? Because to the left it actually pulls the graph more to the right. Sorry, if you use negative values, it pulls the graph to the right. If you use positive values, it makes pulls the graph to the left. Okay, so that's just how it works. It's kind of funny. It's backwards that way. What did we say m was? I'm not sure. I can't remember. But whatever we worked it out to be, let's pretend it was 18 and 5. Okay, sorry, 5 and 18 would make more sense. And so it's 5 and 18, okay? There we go. So now remember that this is P and this is Q, okay? So we're adding 1 to Q, so Q becomes 19. And we are adding 2 to P, so this becomes 7. That's all, right? So this moved, let's witness it geometrically. This moved, well, we moved it, didn't move, 1 unit down, no, 1 unit up we said, so that became 19, right? And it moved 3 units to the left, okay, and that number changed as well. Oh no, sorry, that would have increased, right? That would have increased. This would become 2, right? From 5 it would have been 2, because it had to move 2 units to the right. So 3, yeah, because if it was originally 5, it would now have to be 3, right? So you just see there, I got a little bit mixed up, but yes, essentially you're just moving it around. Now if you're changing it in the equation, okay, in its equation, if this was in turning point form, then you would add instead of subtract, okay, if you move it to the left, and then, yeah. But when you work with actual values, you can see it's going this way, so the number can't get smaller, but basically that's it, okay? Then reflecting about the y-axis, what's happening? Reflecting about the y-axis, what is that? What does that mean? And this is our y-axis, right? To reflect about it, our parabola will now look like this. Okay, and what happens there? What had to happen? What had to happen? Well, what had to happen was that every single x value, the sign had to be changed. That makes sense, right? Because look, at this point here, this sign had to change and be flipped to come to this point. This point was changed and flipped here, right? Or wherever, here. So that's basically what happened. So we're flipping the x values. So to shift it about this line, right, we had to change all the x values. So f of x reflected about the y-axis becomes f of negative x. And that helps us when if you want the new equation, because you substituted this negative x into there and you get a new equation. Conversely, if we have a reflection about the y-axis, right, that means the parabola is going to be like this, okay? It means our parabola is going to look like that, okay? So this turning point, the y value now was switched. We switched every y value. If this was an 18, our turning point shall be a negative 18, right? Because we flipped it completely. We just did that, right? We flipped it. And so we're flipping every y value, and we know the y value is represented by this number here, this thing here, g of x or f of x, whatever the case is. So f of x reflected about the x-axis actually becomes negative f of x, which means that how would we show that? Well, we would say this is f of x, and we want to find negative f of x. We put a big bracket here, and we put a minus in the front, and just take the minus in and change all the signs. That's what that means. If we wanted f of negative x, wherever there's an x here, we just put negative x inside, right? And work it out, and then get the new equation. That's just that. And yeah, if you have any more problems or questions, just let me know.